All right, so here is your Python review for exam 1. So one thing that you'll be asked to do is look at little code fragments and then be able to determine what the output of those fragments would be. So here we have A equals 3, B equals -5. Then the next line is A equals B. So that means we're taking the value in B and we're assigning it to A. So A will now have a -5 in it. Then we're setting B equal to 2. So then that's going to have a 2 inside of it. Then we're saying X equals A times B. All right, so X is going to have a -10 in it. And then the last line is just to print out X. So we would be printing out a -10. All right. If we look at the next one, we say A equals 5. All right, so A is 5. And then we're printing out A minus 3. So that's going to print out a 2. But notice that A itself doesn't change because we didn't use the assignment operator here. We didn't use the equal sign, so it stays 5. Then we do A equals A plus 1. So that's taking the old value, adding 1 to it, and giving us the new value of 6. Then we have B equals A. So again, that's taking this value in A and storing it in this new variable B. And then it says to print out B, so that's just going to print out the 6. All right. Here we have print 14, and then the 2 division signs mean integer division, so we just cut off the decimal. So 4 goes into 14, technically, 3.5 times, but that decimal gets cut off. We don't round it, we just cut it off, and we say that the answer is 3. All right, this is the remainder operator. So how much is left over when we divide 14 by 4? Well, it goes in 3 times. 3 times 4 is 12. So there must be 2 left over because 14 minus 12 is 2. So there's 2 left over. The remainder of 14 divided by 4 is 2. All right. So here we're using the square root and the power function. So remember, the first number is your base. The second number is your exponent. So what this line of code is saying is the square root of 2 to the 5th plus 4. All right, that would be the mathematical calculation that's happening there. 2 to the 5th is 32. 32 plus 4 is 36. The square root of 36 is 6. All right, so here we have a variable with the word Abe being stored in it. Here we have a variable with the word Lincoln stored in it. And then we're saying first plus last. So when there's 2 strings and you add them together, it just sticks them together. But make sure when you're writing this out, you don't have a space, all right? There's no space there. They're just going to be stuck right next to each other. All right. And then the last one says print first times 2. All right, so what that's going to do is it's just going to print the word Abe twice in a row. Again, no space. All right, consider the 2 functions below. Def tax, which has 2 inputs, an amount and a rate. And then it does print t equals amount times rate, and then it prints out the result. And then we have def calc, which wants a and r. And then it calls the tax function. It does its own calculation, and then it prints something out. So what would be printed out by each of the following Python commands? So if we just call the tax function, right, 200 would get stored inside of amount. 0.07 would get stored inside of rate. We would do t equals amount times rate, which basically means 200 times 0.07. And then we would print the word tax. The comma isn't printed. That's just showing that this next part is a variable. So the variable t is going to have the product of these 2 numbers inside of it, which happens to just be 14. So this would just print out tax 14. Now, when we do calc 100 comma 0.05, 100 and 0.05 get stored in A and R. So A now has the number 100 in it. R now has the number 0.05 in it. All right. We then call the tax function. All right. And we send it A and R, which we know has the numbers 100 and 0.05 in it. So now our program jumps up to here. All right. We do this calculation, 100 times 0.05. All right. Then we do this print line. So on the output screen, you're going to see tax 5. Then this function ends. We go back down here. We do the calculation G equals A times 0.2. So basically 20% of 100. And then we print out tip. And because it's a new print statement, it would go on the next line. And it would be tip 20. All right, so you need to be able to kind of analyze functions, analyze calls to functions, and understand how the numbers and the inputs flow throughout the program. All right, moving over to the back. Consider running the code fragment on a 3x2 picture. Pick below. On the 3x2 picture, mark the changes that are made to the code fragment. All right. Help if I had the document in the right spot. So px equals get pixel of pic 1, 0. So again, this first one is your x. The second one is your y. And then it's important to remember with a picture, you start with the coordinate 0, 0. So this would be x of 0, x of 1, x of 2, y of 0, y of 1. So these are your y's, these are your x's. So this is saying get pixel 1, 0, which is this one right here. Then px2 is getting pixel 2, 1, which is this one down here. Then we're saying set red of pixel 1 to 0. So this R20 is going to go away, and it's going to become R0. Then we're saying G equals get green of pixel 2. So this variable G that we're creating is going to have the green value, which is 50. And then we're saying set blue of pixel 2 to G plus 10. So we're going in and we're changing the blue value, not the green value, but we're using this 50 that we got, and we're setting blue to 60. So blue would then be 60. Okay. Let's look at the next one. All right. And again, I'm going to do the same exact thing that I just did, where I'm going to say, all right, this is my y side, 0, 1. This is my x side, 0, 1, 2. And by forcing myself to label it, I just decrease the chances that I'm going to make a silly mistake. All right, so this one says for p in get pixels of pic. So get pixels, remember, is going to create a list of every single pixel in the picture. So we know we're doing this for every single pixel. And then G is going to get the green value. And then we're going to set green to 255 minus G. So we're basically doing that inversion that you saw in lab 2, where we're inverting the green. So we're just going to go through the pixels one by one by one. So 255 here is going to get inverted, and it's going to become a 0. All right, because we're going to do 255 minus 255, and that's going to give us 0. Here, we're going to do 255 minus 0. So that's going to become 255. Here, we're going to do 255 minus 100. So that's going to become 155. All right. Then we go down here, and we're going to do 255 minus 0 again. So that's going to stay 250. We're going to become 255. 255 minus 5. So that's going to become 250. And then 255 minus 50. So that's going to become 205. And again, these are all my green values. So the only thing I'm changing is the green value, and I'm basically taking the inverse of its original value. All right. So again, when you see this 4p in get pixels, you have to know that that's going to walk through and do the entire picture from start to finish. All right, so this next one has some code written for you, and then you're sort of filling in the blanks to complete whatever needs to be done here. So it says the function should turn the bottom half of a picture red. All right. So if we kind of think about that visually, if here's your picture, we're trying to change this part of the picture red. So not the whole picture, just that bottom half. Now, when we're dealing with our x's, you can see with our sample picture here, the x's still go all the way across the picture. So our range can be from 0 to get width of pick. All right, so we can use our get width function there because we are still going across the entire picture. Now, to get the bottom half, we don't want to start at 0. We do want to go to get height because it's going to the bottom, but we want to start halfway through. All right, so the way we can do that is we can say get height of pick, but then instead of using the full height, we're going to divide that and we're going to do integer division. So that's 2 division signs by 2. All right, and that says we'll start halfway down and then go to the bottom. All right, and we always want to use the double division sign there because you don't want to have decimals when you're using this range keyword. All right, next, it's just knowing what arguments go into get pixel. So to use get pixel, you start by providing a picture object. So in this function, we are calling our picture object pick. And then the next 2 parts are your x and y coordinates. So we can use our x here, we can use our y here. All right. Remember, these are our loop variables. They didn't have to be called x and y, but that's what we called them in this one. So we're going to reuse x and y there. All right. And then set color. All right. We don't set color for an entire picture. We set color for an individual pixel. So we're not going to use pick. We're going to use px here. And we're setting px to the color red. And red is a predefined color in our jest.py file. So we can just say red and it will know what to do with that. Okay. So 6 says rewrite your function from the previous problem so that the color you are changing to is an input. For example, the following calls should work. All right, so basically, same program as up above, but now we're adding a second input. All right, so we would start with our def. I'm still going to call it bottom half. There's no reason to change that. All right, it still needs the picture input, but now we're going to add a second input. And when you have more than one input, we separate them with commas. And I'm going to call this input color choice. All right, doesn't have to be called that. That's just the name I'm choosing to use for it. All right, now the first for loop is going to be exactly the same, all right, because we're not changing where we're making the loop. So for x in range 0, comma, get width of pick. And then I'm not going to forget my colon there. Oh, almost forgot my colon up here. All right, so colon there, colon there. All right, I'm then going to indent and write my second loop, which again is going to be the same because we're still drawing it in the same place. For a range, and I'm going to use get height, and then divide by 2, which is our integer division. Oops, sorry, that should be get height of pick. Sorry, I forgot that there. And then comma, get height of pick. So that's going to go from halfway down all the way to the bottom. And then again, make sure I have all my parentheses here. And then my colon. I'm still going to get the pixel. So this part is exactly the same. Get pixel of pick, comma, x, comma, y. And then really, outside of this, the only other change is down here in set color. So I'm changing this to set color. I'm still doing it on px, but this time, instead of using the word red, I'm using my new input value color choice, and that will have the color inside of it that I need to set it to. So really identical to what we have up here, only we're adding the second input, and then we're using that input down in here. Again, be careful. I mean, don't forget, like pick, like I almost did. Don't forget your colons. Make sure things are properly indented. All right, 7, complete the following function that turns the top left 100 by 100 pixels of a picture white. All right, so again, it's helpful to have a little picture. So it's saying the top 100 by 100, you want to turn that white. Remember, our pictures always start at 0, 0. So if I'm setting this up, I've already got the definition right here. I can just start with my for loop. So I can say for x in range. Now I want to start at the top left corner, so my range can just start at 0. And if I do 0, comma 100, that gives me all the numbers 0 to 99, which will give me a 100 by 100 picture. So I'm going to do this for the x, and then I'm going to do the same thing for the y. So for y in range, 0, comma 100. I've got my colons. Then I can go in here and I can say p equals, or px, or whatever you want to use. It's your call. I'll just use p this time. Get pixel. All right, pick, comma, x, comma, y. All right, there's my picture object. There's the coordinates of the pixel that I want. And then I'm going to set the color of that pixel to white, because again, white is a specified word in just.py, so that will work. If you forgot that this was a word in just.py, you could also do set red, set blue, set green, and set them all to 255. So if you did like set red of p to 255, and you did set blue to p of 255, and you did set green to p of 255, you could do it that way. You could also use the make a color function. But again, white is a pre-specified one, so you can just use that there. 8, write test code you would use to test your function white corner in the previous problem on a picture found in a file called shops.jpg. Save the resulting picture with the white corner to a file called output.jpg. So these are like the 3 or 4 commands that you use every time you're sort of running your program. So it would be something like my pick. And again, that's just my choice. I didn't have to call it my pick. That's just the name I'm giving it. My pick equals make picture, and then a left parenthesis, and they said the file was called shops.jpg, and then close my parentheses. Then I would call my function. So my function was called white corner, and the only input that it needed was a picture, and mine was called my pick. So I'll put that inside of my parentheses. And then to actually output it to the file, I would use my write picture 2, and then I have to tell it what I'm writing it to, so, or which picture I'm writing. So I'm writing my pic to output dot JPEG. All right, so you've been using these commands pretty much every single time you run your code. You do need to be familiar with these exams on the test. You do have to be able to kind of reproduce them if asked. All right, number 9. Add 2 more lines to the function below to make it print the integers from 1 to 100 inclusive. All right, inclusive means that we have to print out the number 1 and we have to print out the number 100. You need to use a for loop. All right, again, it would help if I had the paper in the right spot. Sorry about that. All right, so if we're making a for loop here, we're indented because we're inside of a function. And then I've got for. That's the required part. Then I have my loop variable. I can call this loop variable whatever I want. I'm just going to use the letter I. Then I have the word in. That's a required part. And then I have to specify my range. So I want it to start at 1. So I'm going to do 1, comma. And then if I actually want it to print out the number 100, I can't do 1, comma 100 because that will only go from 1 to 99. I have to go to 1, comma 101. That will give me what I need. And then I have to use my colons. And then to indent inside of that, I would just say print I. All right, so those would be the 2 lines to do that. All right, 10. Show what is printed when the function mystery below is run. All right, so we've got our nested loops here. This one is from range 1, comma 4, which we should know by now that that means we're getting 1, 2, and 3. And this is for range 1, comma 3, which means we should be getting 1 and 2. Okay, so as we go through this, right, k is going to be 1. So let me do this over here. K is going to be 1, and j is going to be 1. All right, it's going to print out k plus j, which means it's going to print out a 2. K is still going to be 1 when j goes to 2. All right, so then it's going to print out 1 plus 2 and give me a 3. At this point, the inner loop has finished, so the outer loop then goes to a 2. The inner loop gets reset to 1, and we're going to print out another 3. Then the inner loop goes to 2, and we're going to print out a 4. The inner loop is finished, so now we go to the outer loop, and the inner loop gets reset. We're going to print out another 4. Then the inner loop goes to 2. We're going to print out a 5. And now the inner loop is finished and the outer loop is finished. So our program has run to completion. So we would get 2, 3, 3, 4, 4, 5. All right. Describe in words what the following mystery function does. All right. So we have for x in range 30 to 70. We have for y in range 0 to 30. Px equals get pixel of pic x comma y. Copy color equals get color of px1. px2 equals get pixel of x comma y plus 30. And then we're setting the color of px2 to copy color. All right. So let's pretend we've got a little picture here. All right. So we know that this is 0, 0. We know that as we go to the right, x gets bigger. We know as we go down, y gets bigger. So if we look at our original loop, we're saying 30, comma 70. So that means it's going to go from 30 to 69. and 0, 30. All right, so the first coordinate that we're going to get is 30, 0. All right, so this would be like 30, 0. And then we're going to go down all the way to pixel 29. So we could say that this is 30, 29. All right, and then we're going over to 69, 0 and 69, 29. All right, so that's what's happening. This is the range that we're looking at. Now, if we see what's actually happening inside of that range, we're basically reading the color, all right? We're figuring out what the color is. And then we're doing that same loop, only 30 pixels lower, and we're copying that color. So we're basically saying, all right, let's read the color in from this section right here, and then let's copy it 30 pixels down below so that it gets the same exact color from whatever that was. All right. So as far as kind of putting it in words, the function copies the colors of the pixels in the rectangle spanning from 30 to 69 on the X and 0 to 29 on the Y. To a new rectangle spanning now the X hasn't changed, so it's still going to be 0 to 69 on the X, and the Y has just bumped up by 30, and 30 to 59 on the Y. All right. So basically, it copies the colors of the pixels in the rectangle from this to a new rectangle from this to this. But it's basically just taking these colors right here in this rectangle and then copying them down below inside of a new rectangle that starts kind of right below the first rectangle. All right. But again, just being able to read and sort of parse what each of these lines means, and then kind of trying to put that all together to say, oh, this is what that function is actually trying to accomplish. All right, complete the following function that turns the bottom center half of a picture whatever color the user specifies, and the sample below the user chose red. All right, so it's hard to tell on this photocopy, but basically there's a rectangle right here that they're shading. So again, it's another one of these. Let's fill in sort of the blanks here. So H is presumably going to be the height of the picture. So we would need our get height function. And we're going to use the pick input that this function defined. Width is going to be get width of pick. Now, we can see that our X starts at W divided by 4, which is basically a quarter of the way through. And you can see that we're not stopping at the halfway point, we're stopping at the like 3/4 point. So this is just going to be 3 times W divided by, and actually both of these should be the double division, so I'm sorry about that, divided by 4, because we don't want to have decimals there. And then for Y in range, right, again, this is another one where we're starting halfway down. So this one's just going to be h divide by 2 there. All right. We don't need to use get height and get width again because we already saved those values in h and w. So now we can just reuse h and w. P equals get pixel of pick at x and y. And then we're setting the color, again, not of pick, but of an individual pixel. So we're setting the color of P because that's the letter they used. And we're setting it to whatever color they specified. So that's using this input here, my color. All right. And then the last one here, complete the function below so that it negates only the red color for every pixel in the picture. All right, so this is 1, knowing the for loop that will do that, and then 2, knowing what it means to negate something. So the for loop would be for, that part's required, and then this is where you choose what you want to use. This is your loop variable. I'm going to use px this time. In, and then we're not doing a range. Instead, we're using get pixels. Right? That will automatically get all of our pixels from the picture. Right. Then we go to R equals get red of px. So that will get us the red value of whatever pixel we are currently looking at. And then to invert that or negate that, we're going to say set red. And we're setting the red of pixel px, which is basically the current one that we're on. And we're going to set it to 255 minus r. So that'll go through and negate everything. Now, you don't have to use this loop. This is the easiest way to do it. You could also do something like for x in range 0 to get width of pick, and for y in range from 0 to get height of pick. But then you'd have to do this whole get pixel, and then you'd have to do the get red, and then you'd have to do the set red. So you could set it up this way, but it would involve a lot more work. And I'll show it here just because some of you might try to do it that way, but this is the easiest way to do it. So the other way you could write this is for x in range 0 to get width. And I'm going to run out of room here, but it's get width of pick, and then I've got the colons there. So hopefully you kind of know what I'm trying to say there. And then for y in range, and the same thing's going to happen. I'm going to run out of room here. 0, comma, get height. And I'm just going to, it should be of pick, but I'm just out of room here, so I'm going to do this. So if you do it this way, then you have to actually go and get the individual pixels. So then you'd have to have a line that's like P equals get pixel, or why don't we use PX so that we're using the same thing? Get pixel from pick X comma Y. Once you've retrieved the actual pixel, then you can do the R equals get red of PX. And then once you've got the red value, then you can actually do the set red of px, comma 255 minus r. All right, so it is possible to do it this way, but this way is going to be a lot simpler. Another thing that some of you were doing in your labs is instead of just using set red, set blue, set green, you were like making an entire color. So you would get the blue value, the green value, the red value, and then you would make a color and just keep red and green, blue and green the same and change red. Again, that'll work, but this is just a much simpler and shorter way of doing it. All right, so I hope this was helpful. If there's anything that you didn't understand or you want me to go back over, just reach out and I can do that for you. All right, have a great day.